Welcome everyone. Today we're going to explore the programming language that powers interactivity across the modern website. It's called JavaScript. On this first slide, I want to set the stage for what's to come. We'll introduce the topic, give a quick overview of what we'll cover, and get you excited about diving into the fascinating world of JavaScript. So let's get started. Now let's talk about how JavaScript works behind the scenes. It runs directly in your browser, which is pretty amazing because there's no need for any extra software or installation. It uses powerful engines like V8 in Chrome, which process the code very quickly. This allows your website to respond instantly to user actions, creating a smooth, real-time experience. JavaScript is a programming language that makes websites interactive and dynamic. Think of it as the engine that drives the behavior of your web pages. While HTML provides the structure, think of it as the skeleton, and CSS adds visual style, like clothing and colors. JavaScript brings everything to life by enabling interactive features. So, when you click a button, submit a form, or see an animation, JavaScript is working in the background to make those things happen seamlessly. That's why understanding JavaScript is so important for building engaging, modern websites. On this slide, we're exploring some of the core ways JavaScript makes websites more interactive and user-friendly. First, we have loading content from servers without a page refresh, which is essential for creating seamless user experiences. Instead of waiting for a full page reload, JavaScript allows parts of the page to update dynamically. Next, we see data fetching. This is how websites retrieve information from servers in the background, making data available instantly without interrupting the user's flow. Checking input before submission is another key point. It helps ensure users enter correct information, reducing errors and improving data quality. Form validation is closely related. It verifies user inputs before sending data to the server, safeguarding against invalid or malicious data. Displaying alerts, modals, and messages is how websites communicate with users, whether confirming actions or warning about issues, making interactions clear and responsive. Pop-up windows are also a common feature, used for everything from login prompts to advertisements, enhancing user engagement. Responding when users click buttons or links is fundamental. JavaScript captures these events and triggers the appropriate actions, keeping the site lively and interactive. Finally, button actions are a perfect example of how JavaScript responds to user input, enabling everything from submitting forms to navigating pages. All of these features show how JavaScript powers real interactions on the web, transforming static pages into dynamic, engaging experiences that react instantly to user actions. JavaScript has really evolved from those tiny scripts we used for simple web page interactions to now powering massive platforms and complex applications. It's become the universal language of modern software development. For example, with the Electron framework, JavaScript helps create native desktop applications, giving us powerful tools to build desktop apps that feel seamless and integrated. On the server side, Node.js allows JavaScript to run on servers, enabling us to develop backend services and server applications efficiently using the same language we use for front-end development. And for mobile development, frameworks like React Native and Ionic make it possible to build cross-platform apps that work on both iOS and Android, saving time and resources while maintaining consistency across devices. We also see JavaScript everywhere in web applications, from interactive sites like Gmail, Facebook, and Netflix, which rely on JavaScript to deliver dynamic, engaging user experiences. All of this highlights a key point. JavaScript isn't just a language for simple scripts anymore. It's everywhere in desktop, mobile, server, and web applications, truly making it the backbone of modern software development. Unlike traditional software, web apps don't require any installation. You just visit a URL, and you're ready to start using the application immediately. Whether you're on the internet or connected to a local network, it's that simple. A web application, or web app, is essentially software that runs on a web server. Instead of installing it on your device, you access it through a web browser like Chrome, Edge, or Firefox. This approach makes web apps very flexible and accessible from almost anywhere, which ties into the overall theme of cloud-based, accessible technology. Let's take a closer look at some of the key points regarding web apps. First, security concerns are definitely something to keep in mind. Since web apps are hosted online, they can be vulnerable if not properly protected, which makes security a critical consideration. Next, performance limits can come into play. Web apps might run a bit slower compared to native desktop applications because they rely on internet speed and browser performance. Speaking of internet, most web apps require an active connection to work, so if your internet goes down, access might be interrupted. On the positive side, web apps offer some clear advantages. You can access them from anywhere with an internet connection, which really boosts flexibility. They also update seamlessly. Any changes or improvements happen automatically on the server, so you always have the latest version without manually installing updates. Additionally, web apps are compatible across all devices with a browser, making them universally accessible. And the best part? There's no need to install anything. You can just open your browser and start working right away. So, while there are some security and performance considerations, the benefits of accessibility, automatic updates, and cross-device compatibility make web apps a compelling option, especially in our increasingly connected world. Let's take a closer look at the key differences between web applications and websites. When it comes to JavaScript use, web applications rely heavily on it. It's essential for implementing all kinds of functionality, allowing for a seamless and interactive user experience. Think about online banking or project management tools. These are prime examples where JavaScript powers complex features and high user engagement. The interaction here is extensive, with users actively participating and customizing their experience. The main purpose is to create an interactive and highly functional platform that meets user needs. On the other hand, websites generally use JavaScript more sparingly. Its primary role is often just for navigation or minor interactivity. Examples include company blogs, news sites, or personal portfolios, sites that are mainly informational. The level of user engagement is limited, focusing more on delivering static content efficiently. The goal is to inform or showcase rather than to provide a dynamic, interactive environment. Understanding these differences really helps clarify where JavaScript truly shines. It's clear that for highly interactive, functional experiences, web applications are the way to go. Conversely, for informational content and simpler user interactions, websites are sufficient. This distinction is fundamental as we continue exploring how to leverage JavaScript effectively in different scenarios. Let's talk about how JavaScript makes our web applications smarter and more user-friendly. First, it helps us check forms before we even submit them. For example, it verifies that the email address is in the correct format and that all required fields are filled out. This means users get immediate feedback, reducing errors and making the process smoother. Next, JavaScript runs directly in the user's web browser. That's a big advantage because it executes immediately without needing any extra software or uploads. This makes deploying updates and features much easier and faster. Finally, JavaScript powers all sorts of interactive elements on the page. Think about buttons, drop-down menus, pop-ups, sliders, and other dynamic content. When you click a button and something instantly appears or disappears, that's JavaScript in action. It creates a richer, more engaging experience for users. All of these points highlight why JavaScript is such a key technology. It enables us to build web apps that are faster, more interactive, and more responsive to user needs. Now, let's talk about the different types of data in JavaScript. First, we have complex structures like objects and arrays, which can hold multiple values all in one container. These are called non-primitive or reference types because they reference memory locations where the data is stored. On the other hand, we have simple, immutable values such as numbers, strings, and booleans. These are primitive data types, and they hold a single piece of data that cannot be changed once created. JavaScript uses these two main categories: primitive types for basic, unchangeable data, and non-primitive types for more complex, structured information. Now that you understand what JavaScript does with these data types, it's time to explore how it stores and organizes all this information behind the scenes. Now, let's talk about the different types of data we encounter in JavaScript. On one side, we have complex structures like objects and arrays, which can hold multiple values. These are what we call non-primitive or reference types. They're powerful because they let us organize and manage groups of data easily. On the other hand, we have simple and immutable values such as numbers, strings, and booleans. These are what we call primitive data types. They store a single piece of information and are straightforward to work with. JavaScript uses these two main categories, primitive data types and non-primitive or reference types, to handle all sorts of data. Understanding these differences is crucial because it affects how you store, manipulate, and pass data in your programs. Now that you understand what JavaScript does with different kinds of data, we're going to dive deeper into how it actually stores and organizes this information under the hood.